Hi guys, we're going to move on to Unit 1, Section 2, Solving One-Step Equations. I'm going to go through some examples with you, and I'm actually going to write down what your thinking should be as you solve an equation. Now I know that some of you are really good at this, and so you could probably go through this video a little quicker than other people, and other people you might need to pause and take some time and really think about this. Remember, you are in charge of your learning. And so if you just ignore what's going on and you just go through it as fast as you can, that's not going to help you understand this. Okay? So we're going to do, it looks like I have 6 examples for today that I want to get to do. And then tomorrow we're going to do a lot of these because solving equations is the foundation of Algebra 1. So let's start with our first example. Our first example is x plus 3 equals 7. Now, oftentimes I'm going to talk about 2 different sides of an equation. And what I have found over the years is I've made the assumption that people know what 2 sides of the equation are. And maybe you know what that means, but if you don't, here's what I do to remind myself. I draw a line. Oh, I don't like where my equal sign is, so I'm going to fix my equal sign first. I draw a line down the equal sign, and that shows me which is which side of the equation. So now I can see I have a left and I have a right side of the equation, okay? And so when I'm talking about sides of the equation, that's what I'm talking about. Now over here, I'm going to actually write down my thinking as I go through these problems. So my first thought is, I don't like that. I'm going to make that thinner. Okay. My first question is going to be, what wants to be alone? Now, as you get used to my teaching, I like to connect my teaching to things that in the real world. And in this case, I think about my variables as bratty kids in preschool. Maybe you were that bratty kid, or maybe you knew one. Remember that kid in preschool who couldn't sit next to anybody? Always had to be by himself, had to have space. In fact, I have a couple high school students. They don't bite, but they need a little space. And so I always think of my variables as that preschool student that needs some space and needs to be on one side of the equation alone. Okay? And so what wants to be alone in this case is the letter, but we don't call it a letter. Let's use real math terms. It is a variable. The variable wants to be alone. Now, if you remember from lesson 1, a variable can represent a number. Okay, we don't know what that number is, but it represents a number. Now, I'm going to change my variable to blue, just so you can see what I'm talking about. Now, the next question I ask myself, and this may not seem important right now, but later in the unit, it's going to be important. What is the variable? And the reason it's going to be important is later we're going to have more than one variable. We're going to have to be able to solve with all kinds of letters, and we need to know which letter wants to be alone, which variable wants to be alone. Now this one is kind of obvious because there's only one letter, and so the answer to that is X. Okay? Now my next question, and I go through these questions as I'm doing algebra, especially as I get to the higher up stuff. I need to make sure I know what's happening here, and in this case I want to ask basically, what is the problem? What kid is sitting too close to that X? What is crowding the variable? And I also want you to include the operation. And I want to know what operation is going on. And in this case, what's crowding the variable is a plus 3. Notice I put the plus. That's going to be key for the next question. And I'm changing the colors because research has shown that colors help some people understand concepts better and connect them better, okay? So now we have to ask, what is the opposite operation? And for those of you who already did this problem, sometimes you probably don't think through these questions, and you really are going to have to start disciplining yourself to think through these questions especially when we get to all letters in a problem. What is the opposite operation? Well, if we had a plus 3, the opposite of plus 3 is going to be minus 3. So we're going to minus 3. That's how we're going to move that out of the way. But if you remember from pre-algebra, there are very specific rules in algebra. The reason I love the algebra is the rules never change. If I'm doing Calc 3, the rules of algebra are not going to change. And the rule is Whatever you do to one side of the equation, you have to do to the other side. So I'm going to write exactly as I said it. Whatever you do to one side, whoops. And I hope you're writing this all down, because if I think it's important enough to write down, you should be writing it down in your notebook. Whatever you do to one side of the equation, you must do to the other. If you don't, you've now created an imbalanced equation and your answer is going to be incorrect. You've broken the rules of algebra. Algebra is really a game, and you just have to learn all the rules and follow them. Okay, so in this case, what did I do to one side? I minus 3, so I'm going to minus 3 from the other side. Now, if you have trouble with negatives and positives, we're going to keep working on them, and you need to let me know that. But when it comes to doing algebra, here's the deal, and you're going to hear me say this a lot. We have only so much working memory. If you are having a hard time with positives and negatives, and you're also trying to learn the algebra, that's too much working memory at once. So we're going to pull out our calculators if we have trouble with positives and negatives, and we're going to use that to free up working memory just to concentrate on the concept we're working on. If you want some more time and you need to work on positive negatives, we can do that at a separate time and use all your working memory for that. Okay, so let's see what happens here. So some of you already know we have a 3 minus 3. Well, that goes away. That becomes a big fat 0. Okay, so that's gone. I don't need to write 0 down. We have zeros all over the place. So all I'm going to do is write down the x. Now notice I'm keeping my equal signs lined up on the line. Okay, I want to see that. And then I have 7 minus 3. Well, 7 minus 3 is going to give us our answer, which is 4. Okay? Now sometimes I'm going to ask you to check your work, and I'm going to do a couple checks. I'm not going to do a whole lot of checks. If I was going to check my work, this is how it should look. Checking is not the same as solving, so be very careful. The first thing you're going to do is write down the original equation that I gave you. X plus 3 equals 7. Now, instead of trying to move things from side to side, we're going to keep everybody on the same side. And then I'm going to do this. I'm going to say, well, I think that x is 4. Now, this I'm going to pound into your head all year. Whenever you replace a variable with a number, always use parentheses, because half the time you're going to get it wrong if you don't. So I'm going to 4 plus 3, I replace the x with a 4, and I'm asking myself, does that equal 7? And so I put a question mark over the equal sign. Again, this is a pretty simple check, and most of you wouldn't have too much trouble with it, but I want to make sure that you start to get these concepts, because we're going to use these in more complicated problems as we get through more of the math. And in this case, you can see it's true. Well, if it's true, here's the fancy way of saying it. 7 does equal 7, and I put a check mark over it, okay? And that's my check. Now, even those of you that know algebra really well, I'm about to give you some things that, these are kind of my pet peeves of algebra. And so I kind of want you to write these down, and then we'll get back to doing some examples. Here are a couple of my pet peeves of algebra. Okay, this is not algebra. And so don't say these things to me because they're not algebra. And I'm an algebra teacher. I used to teach middle school, but I don't anymore. All right, the first and most annoying thing that I hear is I did it in my head. Well, you know what? Most of us can do it in our heads. Most of you, if I said to you, what was x plus 3 equals 7, what's x? You could do that in your head. That doesn't tell me that you're the smartest kid in the world. And I don't care about that kind of stuff. What I care about, are you working hard and are you trying to learn? If you did it in your head and you simply get the answer, you are doing arithmetic. And arithmetic is 6th grade math. Actually, probably lower than that. Let's call it elementary math. And we're not in elementary school anymore. So if you're telling me, I did this in my head, you're telling me I know how to do elementary school math. Well, that's great. I kind of assumed you did. So please don't come telling me I did it in my head, because this is not about the answer. This is about the algebraic process. And so I don't want to hear that. So we're in high school and you need to show me your work. Now, when you show me your work, I do not want to see this. This is also not algebra. I'm going to put a big thing around this. This is, again, arithmetic, which is a low-level skill, which we're not doing here. I also don't want to see this. If you see a problem like, I don't want to see this. X plus 3 equals 7, and I don't want to see the minus 3 up here. The reason I don't want to see it up there is because later we're going to get into very complicated problems. Some of you write very small, and if you haven't figured it out, I'm a little older, and seeing that small I can't see. So I want to see it line by line. I don't want to see this. 7 minus 3 equals 4. Again, arithmetic, not algebra, and so I won't accept that. I don't want to see, oh, here's a couple things I don't want to see that we're going to do in a minute. I don't want to see 2x divide by 2 equals 8 divide by 2. And I'm going to show you what I want to see instead, because I don't want to see it going linear. I want to see it going down step by step. So I could number the steps. If you do it like this, I don't know what step you're on. And I never want to see a fraction in a fraction. I never want to see 5 divided by 1/3. If I asked you to explain to me what that means, I don't think you would know what that means. I think you'd have a hard time explaining it. I can explain it to you, but it's a rough thing to explain. Division by a fraction is not an easy concept. And so I don't want to see this. We're going to talk about the reciprocal instead when we do these problems, okay? So any of these things, if you did them, you need to go back and fix them because you did wonderful elementary work, but that's not what I want. And I don't want to hear I did it in my head. That is, I don't care. I want to know that you can do the process, okay? So I'm going to move a little bit quicker through 2 and 3, and some of you probably have this already, but you can write this down. And I'm going to ask myself the same questions from above. So if you forget what to do, come back up here to these questions and ask yourself the question, okay? So let's do number 2. We're still adding and subtracting right now. So we have 15 equals y plus 2. This just looks a little different, but the questions are going to be the same. First question, what wants to be alone? Well, in this case, y does. So the letter that wants to be alone is y. Second question, what's crowding my y? What's causing the problem? Why is y getting all mad and wanting to bite somebody? And what operation is attached to it? So in this case, we have a plus 2 that is in the way of the y. Again, look where it is on the side of the equation. The y, it doesn't matter what side it's on, it just wants to be alone on that side. So then what is the opposite operation of plus 2? And whatever the opposite operation of plus 2 is, we're going to do that to both sides. That's how we follow the rules of algebra. So we're going to subtract 2 from both sides. And so we get y equals 13. I'm not going to check this one because I don't want you watching a video for hours on end. We're just going to move to the next one. And what I would like you to do with this next one is I want you to write it down and I want you to pause the video. And I want you to go through the steps that I told you in number 1. And I want you to try this on your own and see if you get the right answer with the correct steps. I do not want to see what x equals if you haven't shown me algebra. So pause the video here. See if you can work it, and then come back and look and see if you got the right answer. Okay, you should only be watching this now if you have an answer and you have steps. So the first question I asked myself, what wants to be alone? In this case, x is the only letter, so x is the variable that wants to be alone. Oh, you know what I forgot to draw? I forgot to draw my 2 sides. So I like to have my 2 sides very obvious to me, okay? So what is crowding my variable, and what's the operation? In this case, it's a minus 3. So we're going to have to add 3, and don't forget, we have to do it to both sides. Why is that? The reason we need to add it to both sides is to keep our equation balanced, to follow the rules of algebra. Now again, if you don't know your negatives and positives, get out your calculator and do -4 plus 3. And -4 plus 3 is -1. Now here's what I'm going to ask you to do. If you got it right, awesome, move on. If you got it wrong, I want you to pause the video and see if you can figure out your mistake. If you can't figure out your mistake, I want you to write a question over here. So that tomorrow when you come into class, you and I, or I can get someone to help you, or Miss Sally or Miss B, we can sit down and figure out what your mistake was. But it's more valuable if you can figure it out yourself. Did you add incorrectly? Did you move the 4 instead of the 3? Did you subtract 3 from both sides? You forgot to add 3? The more you can find your own mistakes, the more you're building connections in your brain that are going to be very valuable for your logical thinking in the future, and also for math. All right, the next thing we're going to move on to now, and this will be, I have 3 more problems, so I know it's a little long, but I'm going to go see what we can do. We're going to multiply, divide when we're solving equations. Okay, and again, some of you have seen this recently, and some of you have seen it recently, but you were having a hard time with it, so that's why we're hitting it one more time. Okay, if we have 2x equals 8, first thing I'm going to do is I'm going to draw my line so I know which side is which. Okay, I'm going to ask myself the question, what wants to be alone? And in this case, what wants to be alone is the x. Now, what is crowding the x and what's the operation? I'm going to write this over here just so we remember. What is crowding the x and don't forget to tell me the operation. I don't know why I just made a Q. Operation. In this case, if you're not sure what this is, if 2 letters are next to each other, I mean a number and a letter are next to each other, or 2 letters are next to each other, there is actually an invisible dot in here. You're going to learn a lot about invisibility here in algebra. There's an invisible dot. So we are actually multiplying the x by 2. So multiply by 2 is what we're doing here. Okay, so I put the 2 and I have a multiplication. So then remember, the next question, our series of questions, we ask ourselves, what is the opposite operation? Oh, I put operation. I forgot to put opposite. Opposite operation. In this case, it's going to be divide by 2. Now, before you start writing divide by 2, that is correct, but we're going to use different notation. I really don't want to see this. We're going to get away from this symbol, okay? We don't want to see that. I want to see this instead. We're going to divide by 2. Divide by 2. It's just a little bit easier symbol when we're doing algebra. It is not that the other thing is wrong. What I'm trying to teach you is what is the most common way to do these problems. Now, what happens to 2 over 2? Well, 2 over 2 means 2 divided by 2. Well, if you're not sure what that means, get out your calculator and go 2 divided by 2. Pause the video, and I want you to actually do that so you can see why we're doing this. The reason we're doing 2 divided by 2 is so that we can get a 1 here, because 2 over 2 is 1. Well, what's 1 times any number? 1 times x is just going to be x. And that's what we want. We need x by itself. And then we have to do 8 divided by 2. Again, if you don't know your divisibility, use your working memory for the algebra, do the arithmetic in your calculator for now. So 8 divided by 2 is going to be 4. And that's your answer here. Okay? Let's go to number 5. Let's bring in fractions. I'm going to say this to you a lot. Fractions are your friends. Don't be afraid of them, but they're the kind of friend that you can only tolerate for so long and then you need it to move away. So we're going to make this move away. I try to get rid of fractions pretty quickly. So let me do a line here so you know that's part of the other problem. I'm going to ask myself the same questions as I did before. Always the same questions. First of all, what wants to be alone? Well, first of all, let's draw our line. Then what wants to be alone? Oh, well, as usual, in this case, x. I like x's better than any. And then what's crowding it? 1/3. So I'm going to write that over here. What is crowding my variable? And what's the operation? And this is where it can get really weird. And this is where I'm going to tell you something easier. I'm always going to give you the easier way of doing it, okay? I might not give you the shortcut. You're going to have to work for shortcuts. But I'm going to give you the way that's going to make it easier for you to do it, okay? Now, what we're doing here is we're multiplying. Let me take this out. We're multiplying by 1/3. But when we have a fraction, instead of, remember I told you I don't want to see this? Because who the heck knows what that means, okay? I don't want to see that. Whenever we have a fraction, I want you to think of the big R word. And some of you have heard this before, I hope. And that's the reciprocal. If we have a fraction, we are going to multiply both sides by the reciprocal. Now, reciprocal just means we're flipping the fraction over. So, flipping the fraction. So, the reciprocal of 1/3 is simply 3 over 1. I don't want to use pink. 3 over 1. Okay? So I'm going to multiply both sides by 3 over 1. Well, do I really need the 1 underneath of it? Really, that 1 is not necessary because 3 divided by 1 is 3. So really what we're doing is multiplying both sides by 3 in this case. So I'm going to do that instead. And I'm going to do this. I'm going to bring it up here. I'm going to rewrite the problem. And I know this is where people who do it in my head, they get mad at me. I don't care. This is what you're going to do, okay? And we're going to multiply both sides by 3. Now, if you want to put the 1 there, you can. The 5 has a 1 under it too. Did you know that? It's invisible. I told you algebra is all about the invisible things. And sometimes we forget, those of us who have been doing algebra for years, that some of you didn't realize that invisible number was there. So as much as possible, I'm going to tell you where the invisible number is. Don't have to write it, but you can. Now, if you're not sure why we did that, if you put in your calculator 1/3 times 3. Well, 1/3 times 3 is really 3 divided by 3, and so we're left with an x. And on the other side, you can do 3 over 1 times 5 over 1. You could do top times top, bottom times bottom, or you can just do 3 times 5, which is 15. And again, I know some of you knew that answer when I wrote this down. That's really good. You know how to do arithmetic, but I need to see the algebra. Let's do one more if you need it. If you don't, you can pause the video. I won't know. Okay, so -5/9 x. You might want to watch this one. This one's a little tricky. Equals 1/2. Okay, first things first. First things first, draw your line so you know your different sides of your equation. Next, what wants to be alone? My x wants to be alone. What's crowding my x? A -5/9. It's a fraction. As soon as I see that the crowding issue, or the crowding is a fraction, you should think of that big R word. And the big R word? Reciprocal. What's the reciprocal of -5/9? It's going to be 9 over -5. Now, it really doesn't matter where you put that negative. It could be in the top, it can be in the bottom, it can be out front, just don't have two of them. Okay, so I'm going to rewrite my problem, and then I'm going to multiply both sides. So I have -5/9 x equals 1/2. And we've decided, since we have a fraction, we're going to multiply both sides by a reciprocal. 9 over -5. Now be careful. It's 9 over -5. Look at the blue. What did we bring to the 5? It's 9 over -5. So that's what has to go on the other side. Be careful. Now again, when we're doing fractions, maybe you've forgotten this rule. It's understandable. There's a lot of rules that have been clogged into your head over the years. 9 over -5 times -5 over 9 is going to cancel out. It equals 1. If you don't know what I mean, then if you do top times top, that's -45. Bottom times bottom is -45. And -45 over -45 is just a 1. So we have an x here. Now you need to get out your calculators. You can do this on your calculator. It's called Math Frac Enter Enter. If you have your graphing calculator, I love this about the graphing calculators are worth the money because it can do fractions for you. You're going to do parenthesis 1 divide 2 close parenthesis. Then you're going to do another parenthesis, or I'm going to need more room. 9 divide negative. Now be careful. The negative key is down by the decimal at the bottom. It's not the same as above the plus, the negative, the subtraction sign. Divide 5, close parenthesis. And here's the cool part. Hit your math button. Now your math button is in the first column right under your alpha key. On most TIs, it's green. And you'll see math, and you'll see the choice of frac. And that is going to be the most valuable thing, I think, on a graphing calculator. And then you're going to hit enter. and then you're going to hit enter again. And it's going to give you a fraction answer, which is beautiful. And the answer is -9/10. Now, if you didn't have your calculator, you need to get one. You can just do top times top, 1 times 9, and bottom times bottom, 2 times -5, and then you get 9 over -10. That means the same thing. If you want to do it that way, I don't like to put it next to it, we can say x equals 9 over -10. That means the same thing. Just don't put a negative in the top and bottom, because what happens if we have one in top and bottom? Now we're talking about a positive number. Okay, I think we've done plenty for today. Your brain's probably starting to get tired. If you are feeling like I still don't understand this, that's okay. Tomorrow when you come in, just let me know that, and we will make sure to get you some more help with dry erase. If you feel like you've got this under control, then when you come in tomorrow, we'll give you the homework, the work in class, and we'll get working on that. But remember, I have to see the steps. If you're not showing me the steps, you're really showing me elementary school level work, and I need to see high school level work. All right, we'll work on this more tomorrow.